Okay, so this next video is about kind of graphs of motion. Specifically, we're going to focus on the distance time graph. So the big thing that you need to do when you're doing any questions is you need to look at the type of graph you've got. So you're going to have time on your x-axis, but check what is on your y-axis. Another video that I'm going to do is also on speed times graphs, and they are interpreted a little bit differently, okay? So with this one, we're going to have distance time graphs, so my distance should be in meters and my time will be in seconds. So let's say, first of all, that we've got a flat horizontal line. Okay, and I see this on a graph. Okay, it could be part of the graph, but if I see a flat horizontal line, if I think that this may be, let's say, this is at 10 meters, okay, it's still at 10 meters, it's still at 10 meters, it's still at 10 meters, it's still at 10 meters. It hasn't gone anywhere, it hasn't moved, okay, which means that it's not got a speed. It has a it doesn't have speed, it is traveling at a constant speed of 0, which means that it is stationary. Okay, stationary is our fancy scientific word for meaning that it's not moving. Okay, on the other thing though, if we are moving, we're going to be traveling at a speed, which means that we're going to be increasing our distance over an amount of time. So for example, with this one, okay, I could be increasing my distance over a certain amount of time, and I might increase it the same amount each time. Okay, if we look at that, we can see that it's a nice linear gradient. So I'm going up the same amount of distance each time. Okay, if I'm going up the same amount of distance each time, that means I'm traveling at a constant speed. Okay. I could also say velocity if I was doing a displacement graph. I'm just going to use speed for the moment, okay? So I could be traveling at a constant speed. But let's say my speed was increasing. If I was increasing my speed, I would be accelerating. And what I could be doing there is I would be covering more distance in a quicker amount of time. So what we actually end up with is we end up with this gradient that goes up and it curves upwards, okay? Because if you look here, I've got kind of a low gradient, it's getting steeper and steeper and steeper. I'm covering more and more distance in less time. So if we look here, okay, over these 3 squares there, I've gone up this amount, whereas over these 3 squares, I've only gone up this amount. Okay, so here I'm going up much more, which means that I must be accelerating. The opposite then is if we are decelerating. Obviously, with decelerating, we're covering less distance in the same amount of time. So my distance is still increasing, but it's going to start curving off and eventually curving back to stationary where it's going to curve down. So that one would be that it's decelerating. Okay, so we're looking at deceleration for this one. Sometimes as well, we also have graphs going backwards and it looks like the distance is going down. If you might see, for example, of stationary, it might go backwards. Okay, it just means here that it's traveling back to its original position. Okay, so let's say I started at 0 and I went all the way up, I stayed in the same place, and then I went all the way back down. Okay, I'm going back to the start, essentially. I'm going back to distance 0 there. Okay, so that one is distance time graphs. Okay, so being really careful. Sometimes just look at the graph and think what's going on. Well, if my distance is increasing, okay, I must be traveling or increasing my speed. Okay, if my distance is staying the same, okay, I must be being stationary. Okay, if I'm traveling at the same amount of distance each time I'm at a constant speed, if my distance is changing, okay, each time, so my gradient is changing, I'm accelerating or decelerating. So then we look at interpreting the gradient for this. So on a distance time graph here, what we've got is we have a nice constant speed. All right, I can see it's constant speed because it's a straight line gradient. And what I can do for that, because we know that speed, I nearly misspelled speed there. Speed is equal to distance divided by time. Okay, essentially for this then, it's also equal to the gradient of distance time graphs. Okay, so in this case, my change in my y, I've gone from 2 all the way up to here. So that's gone from 2 up to 40. Don't know why I've said 1 there. That should have been 2. Sorry, guys. So in that case, that is 12. Okay, I've gone up a distance of 12, and then my time, I've then gone by 20. So sorry, I've gone from 20 all the way back to here to 543. So I've gone a distance of 17. So in this case, if I'm going 12 divided by 17, sorry, I should be able to quickly do that on my calculator. 12 divided by 17. Okay, that is telling me that I've gone 0.70588. We don't like that, it's too many decimal places there, so we're going to just stick to 1 or 2. All right, so 0.71 meters per second in this case. All right, so again, that is calculating the gradient. All right, so if you are doing a distance time graph, all right, to calculate your speed, you're just going to do the change in your y, you're changing your x, so calculating the gradient. So speed is distance divided by time, it's the gradient of a distance time graph, okay? Make sure, again, you've got distance on this axis. It's a little bit different if we're doing a speed time graph or a velocity time graph, so don't fall for that one.